Hello there, PreCalc. It is February already. The year is zipping by. We're studying sequences and series, and sequences will be our topic today or tonight. And we are looking at, we often use the analogy of riding a bike. So I'll show you what it looks like when you're trying to learn a bike. And sometimes it's a little bit frustrating, but then it becomes fun. So let's see what that looks like.
Whoops. Oh, crash. Let's get back up. Okay, you do it? You do it? Okay, you can do it.
That's when the problems are hard.
It's okay, I'll lift it up. There you go. Okay, there
That's
you go.
me speaking encouragement. This is a 2-year-old, by the way.
Okay, you ready? Okay, I'm just gonna give you a boost. There you go.
Yay! Extremely young
Good job, buddy.
to be
You're gonna be
doing
racing
that.
BMX in no time.
How old were you all when you learned to ride a bike?
2 years, 5 months.
Wow. Doing good.
He doesn't mind a crash. He wants to do everything himself.
Alright, so with that analogy, we are looking forward to the fun part, and when we learn to do these problems and always get them right, feels like you're riding a bike for the first time. Let's look at what we're learning in sequences. First of all, if you have some numbers, like say this. Say I have 1, alright, say you have some numbers like this. They are not in any specific order. You cannot tell which number is the first number or the second and so forth. So this is not a sequence. A sequence is an ordered set of numbers. So if I take these same numbers and put them in an order, then you can tell clearly, if we're going from left to right, which number is first, second, and so forth. So a sequence is an ordered set of numbers. We're going to look at sequences, and we're going to see that a sequence is a function. It's because a function is fun. That's why we call it a function. We are going to see that a function is set up, in this case, with the numbers 1, 2, 3, 4, the positive integers. And we are going to take each of these and make them a subscript. So we're going to have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So when you see those, I want you to think of these numbers as part of the domain of a function. And those are the first numbers in the function, and they are going to be associated with another number. So suppose we have a 2, and then a 5, and then an 8, and then a 1, and then a 4. So this is an example of a sequence where we say the first term, often indicated with an A, is, and it's subscripted. This means the first term is 2, the second term is 5, the third term is 8, and so on. So these numbers, even though we just say a sub 1, a sub 2, a sub 3, etc., keep in mind that these are the domain. So these numbers are associated with an output. The input, output, just like a machine, the old function. This particular function has 5 members, so we call it a finite function. And this function has as its domain 1 to 5. its range is the output there. But suppose we change the domain, and the domain is no longer 1 to 5, but the domain is all positive integers. If the domain is all positive integers, back here we would go from a sub 1, a sub 2, all the way to infinity. There'd be all the positive integers. Then we no longer have a finite function, we have an infinite function, where the domain is all the positive integers. And what we're talking about, the domain starting with 1 and going up integer by integer in the positive direction, sometimes we start our domain with 0. So sometimes the first term in your sequence is associated with a sub 0. If I do not say that we're starting with 0, then we assume that we're just going to start with 1. But it's quite common to use a sub 0, and that is fine. It's legit, so no freaking out over a sub zeros. The way we find our sequences is often with a generator. So say this is our generator, and I want you to give me the first 4 terms of the sequence represented by this expression. To do that, this is saying a sub n equals 3 times n minus 2. And if it's not stated, we assume that the first number, if it's not stated otherwise, we assume that the first number is a 1. So we're going to put in a 1 everywhere there's an n. So we say a sub 1, which again is the first term, is 3 times 1 minus 2. So we get the first term is 1. Then the second term, we're going to replace a 2 in for n, and a sub 2 is 3 times 2 minus 2, which is a 4. And if you plug in a 3, you will see that we're going to get a 7. And if you plug in a 4 for the fourth term, you will see that we get a 10. So verify that for yourself. And let's see what's next. I'm just going to set the timer. I forgot to start it as usual. So say I've talked for 5 minutes. So I'll go another 7 on the first part. All right. So let's do another